We can also choose to compare groups with Boxplots. So before we actually compare two groups with Boxplots, let's just remember all of the parts of a boxplot that we learned last week. Remember that a boxplot is based on a 5-number summary, which essentially means that we're breaking our data into 4 parts. We've got the first 25% of data, that's between the upper extreme and the upper quartile, or I guess the last 25%, these are the highest numbers. The upper extreme is the highest data point that's inside the fence. Remember, we talked about the fence last week, and we'll talk about it more today. From the quartile, which is Q3, to the median, that's 25% of my data as well. From the median to the lower quartile, or first quartile, that's 25% of my data. And then from the lower quartile to the lower extreme, that's 25% of my data. So I've got my 25s, basically fourths of my data. Now, make sure that you understand what the fence is and why it's important. When we make a fence, anything outside of that fence is considered to be an outlier. And an outlier is considered to be 1.5 times the IQR away or outside of a quartile. So to find the interquartile range, I'm essentially finding the distance from here to here, IQR, which is Q3 minus Q1. I'm going to take whatever that value is and multiply it by 1.5. Then I'm going to add it to the upper quartile, and then I'm going to subtract it from the lower quartile. So from here, essentially, I'm taking 1.5 of those, and there's going to be a fence. And then I'm going to take basically 1.5 of those, and there's going to be a fence. Now, anything that is outside of that fence is considered to be an outlier. So notice here, I've got an outlier. Looking at this distribution, I'm looking at the age of people involved in accidents based on their role in the accident. So cyclist, driver, passenger, pedestrian. And here are the sample types of questions that you might be asked, basically on how to compare these groups. So for the first question, they ask which role involved the youngest person and what is the age. So obviously I've got a number line here that starts at 0, and it's very clear without too much thought that a passenger must be the lowest age. It looks to be really close to 0, so we're looking probably at a baby. So the passenger less than 1 year, that's the lowest person, lowest age. Which role had the lowest median age? So remember the median, we would be looking at the bars in the middle of our boxes. That's our median. That cuts our data right in half. So it looks like the cyclist and passenger are really close, but it looks like the passenger might be a little bit lower. So the lowest median age would be passenger at about, say, 21 years old. The smallest range of ages, so remember range would be from our highest point to our lowest point. So without having to do any of the math really, I would just look at which one tends to cover the most the smallest range. I was looking at largest. So smallest range would be looking like the cyclist, which would be about 40 years. So the smallest range of ages would include the whiskers as well as that middle 50%. Which role had the largest IQR? Remember, IQR is found by subtracting Q3 minus Q1. So really we're just looking for the longest box, which very clearly is the pedestrian. The IQR is about 44. Again, you would just be estimating based on whatever values you think these would match up with over here. E is definitely the hardest question, so I want you to really pay attention to how we analyze this. This one asks for which role generally involves the oldest people. So a lot of people are thrown off by this. They say, well, look at the passenger. They've got all of these outliers, and it must be passenger. A lot of people say, well, look at the driver because look how long that whisker is. However, we're looking at generally who involves the oldest people. So if I look at, say, pedestrian, I can see from here that at about 47 and above, this is 50% of my data, is 47 and above. Whereas over here, this is only 25% of my data and then some random outliers. Here, my 50% of my data goes from 35 on up. So even though this whisker goes a little bit higher, again, we're looking at where most of that data would be. So 50% of my data is above 75% of the passenger data, and 50% of my data is above 75% of my cyclist data. And if I'm looking between the driver and the pedestrian, Again, even though this one goes a little bit higher, this one has more data up there. So generally, we would say the pedestrian would have the, generally involves the oldest people. I would like for you to try this question on your own, and then there's 4 parts, and then press play to check your work. So this is a side-by-side box plot of sophomore, junior, and senior cumulative GPAs for fall 2012. So first question asked which class had the lowest cumulative college GPA. So again, not generally who's the lowest, but who's the lowest. So that would be right here, whichever one goes the lowest, which is of course juniors at about 1.6. Which class has the highest median GPA? So median, again, the middle bar. So the highest obviously would be the sophomores. It looks to be about 3.2, 3.25, somewhere in there. The largest range for GPA, again, that would be from the ends of each whisker, so that obviously has to be the juniors. And the last question, which has the most symmetric set of GPAs and which is the most skewed? So let's talk about how we look at that. When we're looking at symmetry, we're looking, does each side of the box appear to be about the same length? Do the whiskers appear to be about the same length? So if it's perfectly symmetrical, we would have, and I can't draw a straight line, so you'll just have to deal with it. We're going to have really the same distance for both whiskers and each part. So the closest one to that in our distribution is seniors. The most skewed means that one side's going to have a very short whisker, or all of our data seems to be shoved in one direction or another. And that, in our case, looks like the sophomores. So looking here, it looks like 75% of my sophomore data is kind of on the high side. So from, say, 2.8 or so on up to about 4. So this is definitely more skewed. We've got this kind of smaller bar here, and we've got this longer bar here, and so that tells us that the distribution is skewed.